Okay, so the last two lessons, we learned how to solve systems of equation by graphing or by substitution. But I have to tell you, elimination is probably going to be the one you use 90% of the time from now through Algebra 2, even in geometry and pre-calc and so on. So the thing about elimination is you want to find what's called additive inverses, or basically you're going to eliminate variables like, for example, negative 3x and 3x eliminate each other. So what you're looking for is, we call these additive inverse pairs. In other words, they'll cancel each other out, okay? So before I give you these steps, which I kind of think these are more confusing, so I want to show you, actually I do need to, step one, this is really important, make sure the equations are lined up. So either both need to be in ax plus by equals c, or both in y equals mx plus b. Now, I'll show you what I mean by lined up in a second, but I want to use some examples. Now notice we both of these equations, we have y equals mx plus b. I'm actually just going to use, well, if these two y's are the same exact number, because we're trying to find the solution where they cross, and these have to be the same. So guess what? I'm just going to rewrite this as 3x plus 4 equals x minus 2. I'm not even going to do elimination. This is actually substitution, but frankly, I will never teach you to do a method that's harder than another method. The whole point is you're learning all these methods because sometimes one method is faster than the other. But sometimes one is required over the other. Like if it says solve by graphing, you must use the graph. You can use one of the other methods to check. But my point is, if you ever have where they're both in y equals mx plus b, since both y's have to be the same, I just write, well then the 3x plus 4 has to equal x minus 2. And now all we do is subtract the x on both sides, and then I'm going to subtract the 4 on both sides. So I get 3x minus x is 2x equals negative 2 and negative 4 is negative 6. You divide by 2, and so then you find x is negative 3. So your first coordinate is negative 3 since x's go first. Remember, all your answers are x comma y unless it's no solution or infinite solution. Then I'm going to plug in negative 3 to the easiest equation. Well, guess what? The second equation is the easiest in my opinion. So I'm going to have y equals x minus 2, but the x is negative 3 minus 2. Well, negative 3 minus 2 is negative 5. So I know my second answer is negative 5. Okay. Now, I want you to look at number 2. Notice they're both in ax plus by equals c. The x and the x they don't eliminate each other. They're not opposite signs, basically. Neither will 4y and negative 1y. They don't add to 0. But what you can do is multiply one of the equations by negative 1. Well, guess what? Since this is a 1x, if I multiply the second equation by negative 1, which maybe I'll just show you the shortcut. All you're doing is changing every sign in your equation. Because anything times negative 1 just changes to the opposite sign. But now guess what? What does 1x and negative 1x do? They eliminate each other. So boom. And basically all you're going to do is going to add in like term columns. So I'm going to combine all the like terms together in the two equations. So 4y plus y, because remember we multiply by negative 1, is 5y. And 13 plus negative 3 is 10. Then all you do is divide by 5, so y is 2. So on number 2, the first answer we got was the y. So you have to make sure you put it in the second coordinate. Now, remember the original equation? I'm just going to write it again. It was x minus y equals 3. I'm going to use the original, not the one that I multiplied by -1, just because it's easier to find x. So then I'm going to plug in the y. So x minus 2 equals 3. Add 2 to both sides, and x equals, or sorry, I wrote x. I said x, but I wrote y. Weird. Now the x is 5. So the first coordinate is 5, even though it was the second variable we found. Okay. So let's try that as 5, even though it was the second variable we found. Okay. So let's try that again. At first, this seems really confusing, but I promise when it clicks, you'll fly through it. Okay. First thing I notice is I have a +3 and a +3. Well, 3x plus 3x combines to 6x, so they do not eliminate. But what if I multiply the bottom equation by -1, which changes all the signs? Because you have to make sure you multiply everything, otherwise it does not stay equal. And then now I'm just combining in like term columns. Well, 3x and -3x, now they eliminate. And I can add -10y plus 9y is -1y. And 14 plus -15 is -1. Well, mental math, y has to be 1, but you can also show it by dividing by -1. So the first coordinate we found on number 3 is the 1 for y, which is the second coordinate. Now, I would just choose the easiest equation. Honestly, they both are kind of a toss-up. They're pretty close. I'm just going to use the original first. So I have 3x minus 10 times 1, because that's what we found for our y, equals 14. So I get 3x minus 10 equals 14. Add 10 to both sides, and you get 3x equals 24. Divide by 3, and you find x is 8. So even though it's the second one we found, x always goes first in your answers. Okay, so be very careful. Now in number 4, there's 2 things we can do. Either I could multiply the bottom equation and distribute 2, because then I get a -4x that will eliminate with a 4x. Or notice these 2 y's. I could multiply the bottom equation by -1. Once you grasp this concept of elimination, you have choices. And frankly, I always choose the one with the least amount of work. So I'd rather just change the signs so that I have one positive 2y and one negative, which means I'm going to multiply everything by -1. So that -2x becomes a positive, the 2y becomes a negative, and the 18 becomes a negative. Now I can combine like terms, and the positive 2y and the negative 2y will eliminate. That's the whole point. Then I have 4x plus 2x is 6x, and 6 plus -18 is -12, since there's more negatives. Divide by 6, and x equals -2. I said it, but I didn't write that. And since we found x first, and the x always comes, it's the first coordinate in your answer, we write that. Okay. Now, again, it does not matter which equation you use to plug it in to find y, or plug the x in. I'm going to use the first. So I get 4 times our x, which is -2, plus 2y equals 6. So again, I'm using the first equation to plug in. So that's -8 plus 2y equals 6. I'm going to add 8 to both sides. So 2y equals, well, 6 plus 8 is 14. Divide by 2, or mental math, y is 7. So our second coordinate in our answer is 7. Okay. Now, if you look at the backside, I always kind of scan to see if there's any that I can just multiply by -1. If you look at the backside, I always kind of scan to see if there's any that I can just multiply by -1. Now, guess what? I don't even need to multiply by -1 on number 5. See this 4x and -4x? They already eliminate, so I don't need to multiply anything. I just add straight down because the 4x and the -4x will eliminate each other, and then the 9y plus 7y is 16y, and 5 plus 11 is 16. Well, mental math, y is 1, or you can just divide by 16 on both sides. Well, my first coordinate that I found is the y, so just make sure your answers are always in order. The y is the second coordinate. Now we plug it in. I'm just going to use the first equation. So I get 4x plus 9 times 1, because we know the y is 1, equals 5. Or 4x plus 9 equals 5. Subtract the 9. And then 4x equals -4. Mental math, x equals -1, or you can just divide by the 4. And so our final answer is -1, 1. So if I was to solve both of these equations for y and then graph them, these two lines would intersect at the point -1, 1. Now, look at number 6. Immediately I notice we have a -3y and a 3y. Guess what? I don't need to do any multiplication because these eliminate automatically. So 10x combines with -2x and you get 8x. 18 plus 6 is 24, so I divide by 8 and x equals 3. So on number 6, the first coordinate we found is 3. I'm going to plug it into the second equation. So I get -2 times 3, plus 3y equals 6. Well, that's just going to be -6 plus 3y equals 6. So I'm going to add 6 to both sides. So I get 3y equals 12. Well, mental math, or divide by 3, y equals 4. Since 12 divided by 3 is 4. So then our second coordinate is 4, and the two lines intersect at 3, 4. Now, number 7, I would notice that these are already lined up for substitution. So you can go ahead and do substitution. I'm fine with that. But if you want, you could also subtract the 3y to the other side. Yeah, you know what? I'm just going to have you do the substitution, because you already know that. So let's just substitute the 3y plus 11 into the second equation for the x. So I'm going to copy the second equation, and instead of writing the x, I'm going to write 2 times 3y plus 11 equals 16. Oops, what did I forget? Sorry, I was distracted by the lights going out. I forgot the minus 3y equals 16. So now I distribute, and I get 6y plus 22 minus 3y equals 16. I'm going to combine the 6y and the -3y. I'm also going to go ahead and subtract the 22 on both sides. 6y and -3y is 3y, and then 16 and -22, there's more negatives, and it's going to equal -6. Divide by 3, and y equals -2. So on number 7, the first coordinate we found was the y. So make sure you put it in the y position. Now I'm going to plug it into this equation, the top equation. So x equals 3y plus 11, but we know the y is -2. Well, that's just -6 plus 11, which is 5. So the x equals 5. So we put the 5 in the x position. Okay. Now number 8, I love these problems because automatically -y and y eliminate. Boom, we're done. In terms of we don't have to find or do multiplication so that the variables eliminate. Now I just combine, well, what's x plus 3x? That's 4x. And 10 plus 8 is 28. Divide by 4. And x equals 7. So our first answer on number 8 is 7. I'm going to plug it into the first equation just because it's a little bit easier. So instead of x minus y equals 10, I'm going to get 7 minus y equals 10. Subtract 7. Keep your negative y. Don't lose that. Even though these eliminate, you get negative y equals 3. Mental math, or divide by negative 1, and y equals negative 3. And we found the point where they intersect. All right, now look at number 9. We're so close because the 7x and the 7x, well, they don't eliminate. It equals 14x. But remember I said you can go ahead and multiply one of the equations by negative 1, which changes all the signs to the opposite. And guess what? Now the 7x and the negative 7x eliminate. And then all I have to do is combine 7y plus negative 10y, which is negative 3y, and 28 and negative 22, which is positive 6, because there's more positives, divide by negative 3, and y equals negative 2. So the y is negative 2 for our final answer, so just make sure you put it on the second coordinate. And it doesn't matter which equation. I'm just going to use the top equation. They're both fairly equivalent in terms of difficulty. So I have 7x plus 7y, but the y is negative 2, equals 28. So that's 7x minus 14 equals 28. Add 14. So 7x equals, well, that's what? 42. Mental math, or divide by 7. And x equals 6. So the x coordinate is 6. Okay. So I hope you're starting to get the idea. Now number 10, I wouldn't do substitution, even though the y is almost, or it's almost in slope-intercept form, but you don't want to use substitution if you're going to get fractions. If I divide by 4, I'm going to get a fraction for the slope. You don't want to do fractions when you're substituting. So guess what? I'm just going to subtract the x term to the other side. So, I don't have much room. I'll just show you over here. So if I take the 4y equals 2x minus 8, I'm going to subtract the 2x to the other side. Basically, I'm going to get it in standard form, so that ax plus by equals c. So I have negative 2x plus 4y, because it's a positive 4y, equals negative 8. Now, see how the second equation, I'm just going to write it underneath, is 5x minus 4y equals 20? Well, beautiful thing is that positive 4y and the negative 4y line up and eliminate each other. But the only way you can eliminate is if they're on the same side. In other words, both equations are either in ax plus by equals c, or both equations are in the y equals mx plus b. So here, since they already eliminate, I don't have to do any multiplying. I have negative 2x plus 5x is 3x. And then over here, negative 18 and 20 is 2. Wait a second, did I multiply that wrong? Oh, guess what? It's negative 8, not 20. So this is my mistake. Oh, I copied that wrong. Yeah, I had it up here. I don't know where I got the 18 in my mind. But negative 8 plus 20 is going to be positive 12. So you divide by 3, and x equals 4. So that's your first coordinate on number 10. So I'm going to put 4 in the first coordinate for x in the answer column. Now, it really doesn't matter. I'm going to use this equation to plug in the x's 4. So I have 4y equals 2 times 4 minus 8. Oh, this will be easy because, well, 2 times 4, 8 minus 8. So 4y equals 0. Well, mental math, 4 times what equals 0? Well, y has to be 0. Or you could divide by 4 on both sides, and 0 divided by 4 is 0. So the y coordinate is 0. Okay, those are really easy. Now, look at number 11. Right away, I would notice I don't have opposite signs. I have the same sign. So they're not going to eliminate. Like 3x combined with 3x is 6x, and negative 4y with negative 4y is negative 8y. So nothing eliminates. So I'm going to multiply one of the equations by negative 1, which remember, when you multiply everything by negative 1, it just goes to the opposite sign. So we get a negative 3x, positive 4y, and a positive 13. Now we just combine the terms, 3x and negative 3x, that eliminates. Negative 4y and positive 4y also eliminate. So we get 0 equals negative 10 plus 13 is 3. Well, remember when we said the equations when all the variables eliminate and you either get a true or false statement? Well, all the variables eliminated and we're left with 0 equals 3, which is false, so that means there's no solution. In fact, if we graph these, it would be parallel lines. Okay, now one more on this page. If you notice, they already are going to eliminate each other, so I don't have to multiply by anything. 2x and negative 2x, they eliminate, but so does y and negative y. But remember, that's okay. When they eliminate, it equals 0. Negative 2x and 2x is 0, y minus y is 0. But also, the negative 10 plus 10 is also 0. But that's okay. Remember we said, if all the variables eliminate, you're either left with a true or a false. Well, guess what? 0 equals 0 is true, so this is infinite solutions. It doesn't matter whether you have 0 equals 0 or 7 equals 7. So if we graph these, they would be exactly the same line. That's why we get infinite solutions. So please bring questions to class for clarification.